It's still cold. I still don't have power, but we're still working on factoring expressions here. And today we're going to factor when the leading coefficient is not 1, we'll say. It's really when it's greater than 1. It's probably most of what we'll see, but when it's not 1. Now, okay, we've got some terms here. A coefficient is just whatever number I have in front of my variable. So, you know, like 3x, the 3 would be my coefficient. Or 2x squared, right? The 2 would be my coefficient. So that's what a coefficient is. And the leading coefficient, well, if I have something like this, shoot, I don't know, 2x squared plus, well, I don't know, (3x plus 1), maybe that'll work. I'm really not sure here, honestly. We're gonna see. I think it'll work. Okay, so 2x squared plus 3x plus 1. The leading coefficient, maybe we can get, is 2. Right there. That's that leading coefficient. Now, in the past, you've seen ones with a leading coefficient of 1. That would be like x squared plus 3x plus 1. So that would be a leading coefficient of 1. Now we're talking about how do we factor when there's a leading coefficient that's not 1. Well, a way that can help you think through this is what we call splitting the middle. Okay, and in previously we would have said what numbers multiply to 1 and add to 3. Now, and we call this our big X method. Now I'm looking for up here what numbers, the first number times the last number, what multiplies to the first times the last, so that's 2 times 1, and adds to 3. So what two numbers, and those are the two numbers that I'm going to put here and here, what two numbers multiply to 2 and add to 3? Well, the only numbers that multiply to 2 are 2 and 1, and 2 plus 1 just happens to add to 3. So then I would go ahead and split this middle term. 2x squared plus 2x plus 1x plus 1, and that's it, right? I don't have anything else. 3x is 2x plus 1, so I'm just splitting up my 3x into 2x squared plus 2x plus 1x plus 1, right? 2x plus 1x, that's 3x. All I did was split that middle term up. Now, why did I do that? Well, because I knew that these multiplied to 2 and added to 3. That means that I'm going to have a common factor both here and here. Right? So I'm not multiplying these. These are really just, I'm just trying to show you that I'm grouping these up. So maybe it would be better if I had the plus sign right there. Just grouping these up. 2x squared plus 2x plus 1x plus 1. Now I need to take you back to when we factored out the greatest common factor. What's the greatest common factor of 2x squared plus 2x? Well, I can factor out a 2, right? They share a 2. And I can also factor out an x. And so what's left? Well, 2x squared divided by 2x is x. Oops, I really want this in blue. And 2x divided by 2x is 1. Now here, can I factor anything out really? Not really. You could say I'm factoring out like a 1, but then I still would be left with x plus 1, right? It's the same idea. Okay, now, look, I have this right here, I have the same thing, and this is crazy, right? It's the same on the inside. Can you believe that? And so if I factor out x plus 1, and I know it's kind of weird to factor out a whole thing, but that would give me x plus 1. And then what do I have left? Well, I have 2x plus 1 left. So then if I were to factor out 2x squared plus 3x plus 1, that would give me x plus 1 times 2x plus 1. Okay, that was a lot. So let's see if we can maybe try one more. Just maybe. Okay. So let's try this. We'll do one more and then I think we can call it a day. What if I did 6x squared minus 5x plus 1, minus 5x plus 1. Okay, so using the factoring method that we just came up with, 6 times 1, right? This is a times c. That's my first one times my last one. That's 6. They add to negative 5. So what are two numbers that multiply to positive 6 and add to negative 5? Well, numbers that multiply to 6 are 6 and 1 and 3 and 2. 3 plus 2 is 5, but it needs to be negative 5, so that would be negative 3 and negative 2. Okay, so let me split the middle here, as I've done in the past. 6x, not 6 squared, 6x squared, and maybe I can write it like this, minus 3x minus 2x plus 1. Okay, I split this negative 5x into negative 3x minus 2x. It's the same thing, right? 5 is 3 plus 2, right? Negative 5 is negative 3 minus 2. It's the same thing. So now I need to group these terms up. Kind of group these terms up. And I want to actually rewrite this so that you can see. I'm not multiplying these terms. I'm grouping them into two different parts. 6x squared minus 3x. So that's one group. And then we have that group plus my second group, which is, negative 2x plus 1. Okay, just want you to see that we have these two different groups. Maybe I'll do that second group in blue as well. Okay, Okay, plus negative 2x plus 1. Okay. Sorry, this should have been in blue. Happens. Okay, so now what can I factor out here? Well, here I can factor out a 3x, 6x squared divided by 3x is 2x, 3x, negative 3x divided by 3x is negative 1. Okay, now what can I factor out of this? Negative 2x plus 1. Well, I want this to look like 2x minus 1. So what if I factored out a negative 1? Right? I always want this first term to be positive if I can. So what if I factored out a negative 1? What would that leave me with? Negative 2x divided by negative 1 is 2x. Positive 1 divided by negative 1 is negative 1. And look! I've got the same terms inside my parentheses. That's what I wanted. So then I factor out the 2x minus 1. And if it helps, you can just kind of, right, see what's left. What's left is 3x minus 1. So times 3x minus 1. And that's your answer. And maybe it would be helpful. Oops. Maybe it would be helpful if we actually showed that that answer, you know, this, if we went in reverse, right? Showed that it's the same thing. So if I had 2x minus 1 times 3x minus 1, right? And I distribute the 2x and the minus 1 and the 2x and the minus 1. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. Negative 1 times negative 3x is negative 3x. And negative 1 times negative 1 is positive 1. Okay, 6x squared minus 5x plus 1. That was what we had right here. So it shows that our answer is true. And that's how you can factor out trinomials, or, you know, expressions where a is not 1. That's it. Stay frosty. I'll see you in the next video.